Okay, so let's go ahead and get started. So I am really excited here to introduce our speaker today for the AIR Distinguished Seminar Series. So our speaker today is going to be Bill Freeman. He's the Thomas and Gerard Perkins Professor of Electrical and Computer Engineering over at MIT. Since 2015, he's also been a research manager at Google Research in Cambridge. And generally, his kind of research interests are computer vision, computational photography, and AI for science. He's also a member of the National Academy of Engineering, a fellow of IEEE, ACM, and ACII, and also has a computer vision textbook published by MIT Press. So let's go ahead and welcome Bill Freeman. Thanks.
Hi, thank you. So first of all, thanks for inviting me here. I always wondered what this beautiful building looked like inside, and now I see it's beautiful inside as well. So it's very nice to be here. So this talk is like a palate cleanser in between other fare of late-breaking research. This is a project that took 40 years to complete, and this is the story of that project. Now, if I were you, I'd be probably thinking, okay, 40 years to complete. He probably means that 40 years ago, he said he wanted to do something in robotics, and then now he's finally done something. No, actually, this was a specific design I developed 40 years ago, and then finally it's been completed. And it'll be published in 2 weeks at ACM CHI in Barcelona. Okay. So this is the story of how we got from one place to the other there, across 40 years. So for context, here's me 40 years ago, actually 45 years ago. So I began working in industry pre-PhD as an electrical engineer. And I worked on electronic imaging, and to sort of set the context for what I worked on, here's one of the projects I worked on. So I worked on electronic imaging for cameras and how to demosaic camera data. But here's another thing I worked on, the Polaroid palette. At that time, 40 years ago, there was no good way to get color hard copy out of your computer. And this was a real problem. Polaroid saw a way to make a solution to this and sell more film at the same time. And that was, they made a box that had a TV set inside, a black and white TV monitor, and a color filter wheel, and then this camera on the end that would expose Polaroid instant film. And you would, the computer would control the CRT and the color filter wheel, and it would expose your beautiful color slides or prints for you. So I worked on the software to do those exposures. And here I am there on the left at this Photokina imaging conference in Germany. And so I can imagine that this looks pretty goofy to you, this technology. You know, to get a hard cut, there weren't laser printers, there weren't inkjet printers. We were exposing film to get color output. And just to remind us, the pace of technology is like faster than linear with time. It really is probably quadratic or something. And so if you just think about how goofy this looks to you, perhaps you should keep in mind, or we should all keep in mind, that whatever we're working on now in 40 years is going to look that level of goofy, but squared, okay? Because everything goes faster. So anyway, this is not as goofy as our stuff will look 40 years from now. Okay. So working in industry, I had time to, read magazines and things. Here's an issue of Scientific American from that time. And inside that particular issue was this advertisement, the one on the left. It said, if your idea is so good, we'll help you prove it. And it was about this fund that would give you up to $10,000 to make a prototype of whatever you had invented. Now, there was a catch, and that was it had to be things in these three areas, in the area of clothing, home furnishings, or textiles. And so I read this, and I thought, wow, that's really cool. And it really kind of caught my imagination, even though I didn't and don't work in any of those three areas. I thought, well, I want to try to get this grant and see if I can have my prototype built. And so first of all, a little bit about this grant. It was sponsored by the Innovative Design Fund, and this was founded by a designer named Bonnie Cashin. She worked in the 60s. Now, doing research on her, apparently she wasn't really, I don't think she was independently wealthy herself, but she was really well connected. And so she created this fund to close the gap between an idea's conception and its market availability. So in just reading from the right here, she noted that it could take as long as 20 years, according to her friend and fund's honorary director, Buckminster Fuller. So she's connected there. And then she got a $30,000 grant from the National Endowment of the Arts, a $10,000 grants from New York State Council on the Arts and the Culpeper Foundation. So she kind of was connected enough to know how to get money, and she kind of pooled this money for this Innovative Design Fund. And then in the brochure, in the literature about the fund, it describes, what from the past would they have funded. So she listed 4 things they would have funded. The Murray Space Shoe, which is there on the left. I hadn't heard of it before reading about it. The zipper, pantyhose, and the Eames molded plywood chair. So these are things from the past that they would have funded, from the past relative to the Innovative Design Fund. So I thought this was cool, and I was thinking, well, maybe I could do something with zippers. Maybe I could make a zipper with a new functionality where instead of just fastening things together, how about it becomes a rigid structural support? So that's the thing I wanted to do. Maybe you could use it instead of tent poles or something, just this zipper where it would just become a rigid thing when it was zipped and then be flexible when it wasn't zipped. So that's the design goal. And I played around with this. These are some of the prototypes that I had kept. These flat plates that would go interleave on top of each other, maybe that would work. And then I started playing with this triangular design and came up with this thing. So it has 3 strands of teeth instead of 2, like a conventional zipper. And they're these bars, and they form a triangular column the way you would make a 3-sided log cabin, by one, then the other, and then the other. I think I have a picture of that. Oh, yeah, right. So here's how it works. First, let's review how a conventional zipper works, okay? So here's something being zipped up. You have these 2 strands, and they're offset from each other by half a cycle. They've got these periodic structure, half a cycle offset. The slider coordinates which tooth is ready to fall down onto the stack from which side. So as you push it up, the one that's the set of teeth that is slightly lower down relative to the stack, that pops on the stack next, and then the slider goes up half of a cycle, and then the one on the other side is now ready to flop onto the stack, and it goes down, creating the familiar zip for a zipper. And so I thought maybe you could do the same thing with this triangular structure. So here's how it would work. You'd have the base, and then the thing from one strand would come down, then from the next strand, then from the next strand, and so forth. And the element of the design that would coordinate or orchestrate which one fell down when was this slider as it slid up the set of teeth. So these 3 strands were now offset from each other by 1/3 of a cycle, and then the one that was ready to fall down would be pushed by the slider onto the stack, and then the slider would move up by 1/3 of a cycle, then the next one would slide down, and so forth in this 3-way zipping pattern. So that was the design. Now, so there's kind of 2 parts to it. One is making the teeth and putting them together by hand, and the other is actually designing the slider. So it's easier to make the teeth and put them together by hand. I have to say I lost the original prototype, but I have the next to last iteration of the prototype. I found it. And it's here. And you can, by hand, I won't do it here, but you can put them together and create the triangular structure even without the zipper slider part. So here you can see on the left, I've done that, and you can see how it's, they're falling in place to form this rigid triangular structure. So there you have, when they're unzipped, they're flexible, and then when it's all zipped together, you've got this rigid structure. You can see, so these are Polaroids. Everything I did then was take a Polaroid picture. You can see that the structure supports those books, and so it has this quality of being, when it's in one state, it's a rigid structure. When it's the other state, it's flexible. And then I had to work on the slider. So, and that's the critical part, you know, would the thing actually zip? So a conventional zipper just has 2 strands that come together and make a zipped structure. This thing has 3, and I was pretty sure I knew how sliders worked and that it would actually zip, but I had to build it to be sure that it really would properly coordinate these 3 different strands all falling into place at the right time to make the thing zip. So there's my initial design. You have these this triangular slider, and on each face of the triangle, one of the strands of teeth comes through, and as you pull it up, it has them all flop down one on top of the other. So I built it. Now, I'm not a woodworker, as you can tell, but here's my design. And it creates these 3 channels. Here's one set of teeth falls through here. This part was connected just because it was easier to make the prototype that way, but in order to let the strand of teeth fasten to a fabric next to it, you'd have to actually have this be open for a real slider. And so this would be made out of metal, and it would be strong enough to zip without having this piece there. And it turns out at that time I was really good about keeping notes. So I had a lab notebook that I kept for this project, and also I kept a diary, a journal. So I'm going to show you various things from working on it in the mid-'80s. One thing was, so the punchline was, I made that slider and I put it in the wooden teeth, and it zipped. It really worked. It coordinated the 3-way falling of the teeth onto a column, and I'd done it. I'd done what I wanted. I designed this zipper that was a generalization of a 2D zipper, and it had this new property that, in addition to fastening things together, it would become a rigid structure that you could use for tent poles or chairs or whatever. So I thought, okay, I'm set now. And I wrote down in this journal here, it's 27 years old, perhaps I'll make a ton of money from my zipper idea, ? And I outline how. Procedure, 1, get the rights from Polaroid. 2, get the patent started. 3, contact the Innovative Design Fund for money. 4, build prototypes. 5, go to big companies with my prototypes and sell it to them. Okay? That's the plan. Let's see how it worked out. So first, to get the rights from Polaroid. So the employment agreement I had with Polaroid was pretty typical, but also rather severe at the same time. Typically severe, I guess. And my agreement with Polaroid said that anything I invented, whether it was during work time or during my time, whether it was related to Polaroid or not, belonged to Polaroid. And so I had to get a release from them for this technology I developed. So I contacted my lawyer friends within Polaroid, and they said, well, you know, for Polaroid to give property to you, that's going to take an act by the board of directors, and that's not going to happen. And so they said, but tell you what, we'll go and think about it, and maybe we can get you some release somehow. So then this lawyer wrote back to me saying, okay, because this does not directly or even indirectly relate to the present or future contemplated business of Polaroid and was developed and made by you on your own time, at your own expense, Polaroid will assert no rights therein. Okay, which of course directly contradicted the employment agreement that we had signed with each other, but it contradicted it in my favor, so I was okay with that. And then in my diary I wrote, finally, I have the rights to my zipper. Now the game is to capitalize on it as much as possible. Okay, so that's the plan. And so then I worked on doing the search for the patents, finding related patents, and then also on applying to the Innovative Design Fund. So I wrote a proposal to the Innovative Design Fund, and here it is. I won't read it all to you, but I've designed a new kind of zipper to become rigid like a pole when zipped, but is flexible like an ordinary zipper when unzipped. It can be used as a canvas-based for transport and storage. It can be tents for chairs, purses. There are a lot of applications I thought it could have. So I described that, and I said, well, about me, I've studied engineering and physics. I went to work at Polaroid. During my 4 years as an engineer there, I've learned how to develop creative solutions to engineering problems, yada, yada. And Polaroid's given me the release to this. Okay, sent it off. Oh, yeah, right, sorry, I made illustrations of it. So this is kind of what it would be if you had a really nicely made slider. You could zip it up like a pole, and you could use it as at the bottom right there instead of the tent poles. Maybe you could make a chair out of it by having all these parts be the zipper, and you would just zip it up and it would become rigid. You could make a purse that was, just a bag or a rigid purse as desired. And here's a kind of a nicer picture of how they might, the teeth might fall together onto the stack. And there's a kind of a nicer slider than the one I made. Again, just made out of metal, so it could be structurally solid without having that center piece there that my wooden one had. And I sent it off, and they were pretty quick in the reply. About 3 weeks later, I got a reply, no. And actually, it wasn't the no that bothered me so much as the reasons for the no. Here's why they said no. It was this very legal, lawyerly thing, trying to find a reason to reject it, almost. They said, okay, well, by itself, the support zipper is neither clothing, nor textile, nor home furnishing, so it's not in the scope of the funding. And, first of all, I wasn't happy. Here's my diary entry, and I'll describe it in translating from the language of a diary into what you'd say at a public talk. Gosh darn, innovative design fund person, well, at least they respond quickly, okay? And what really bugged me was their own literature had said that the conventional zipper, the 2D zipper, was something from the past that they would have funded. They listed it as one of the things they would have funded, and that suffers from the exact same reasons that they rejected my proposal, that it was neither clothing, textile, nor home furnishing. So I wrote them right back. I pointed this out in a reply, respectful and everything. I couldn't find the first rejection, but I found the second rejection, the one in response to my rebuttal. And here it is, from nice letterhead, Innovative Design Fund. Mr. Freeman, we have carefully considered your letter to us dated March 18th, 1986, and we regret there is nothing we can add to our last letter to you. Come on, not even, well, good luck, or keep going, or we wish you the best in your future endeavors. Nothing like that. Just, no. Okay, fine. So, and again, I wasn't happy. Shucks, the Innovative Design Fund says no, even to my reasoned rebuttals. Okay, but by now, I had this invention. So it was like, the Innovative Design Fund didn't succeed in giving me money, but they did cause the invention to happen, really. It was from seeing that ad that I developed this thing, and I just wanted to run with it. I wanted to keep going, so I did. So I joined the Industrial Fabrics Association International, and there is one. And as a result, I got all these trade magazines describing uses for awnings and fabrics for furniture. And I wrote to the 3M company and said, I've developed this new kind of zipper that uses fabric to make chairs and things. Can you possibly donate some fabric to me? And they gave me 2 bolts of Cordura fabric, which I actually still have in my basement. So there it is. I contacted the American Fastener and Closure Association. And they said, we're circulating your letter to our manufacturers. Let us know if they don't contact you. And so one of them actually did. The Scoville Corporation. So from reading this letter, I decided that I probably hadn't sent them my design. I just said, I have this new kind of zipper. Are you interested in seeing more? And they wrote back and they said, we would be very interested in reviewing your new zipper as soon as possible. So that's cool. Now, reading back on this, I think, well, why didn't I pursue that? And I'm pretty sure There are two reasons that kept me from following up on this one. One, I was waiting for the patent to be granted because I was concerned about releasing my precious design to them. And also, it was such a lousy prototype. It was just, it was a wooden thing, and I didn't think it was going to persuade anyone. I needed a good prototype to persuade them to license it, I felt, and that's probably true, I think. Okay, so then, so of those two things, the patent and the prototype, let me tell you about the patent work. So again, the top left, that's what I had, this prototype. And I asked the Polaroid people, what's a good patent attorney who I might work with? And said, well, we use Cesare and McKenna. So it was a high-end downtown Boston law firm that does patent work. And I contacted them, and they met me and so forth, and they loved it. It's like a cartoon of the individual inventor, this young kid who has this little wooden prototype on his lap, of a new kind of zipper. And so the attorney I worked with, he brought me into the office of the senior guy, McKenna, the senior attorney, and I showed it to him, showed it zipping up, and they just really loved this thing. And later, working with Bill Cammett, my attorney, on the patent, he said, Bill, I hope you're my first inventor to really make money with this invention. And I thought that was such a telling comment. Wait a minute, you mean to tell me you take all this money from people to file patents and none of them make money? Anyway, I didn't say that, but I just thought it was a very telling comment for a patent attorney to say, I hope you make money with this. Nobody else has. Anyway, so I made drawings for the figures for the patent. So here's kind of my side view of the teeth. And again, there's the top right is the wooden prototype, and then here's my drawing that I thought the figures should look like. Again, wooden pieces nailed or fastened to the fabric thread, the core of the sheets. And then here's the drawing of what the slider could look like. Again, kind of try to make these nice projection views for the draftsman to copy. And the top right is what my wooden prototype looked like. And so it took about a year. No, it took a few months, maybe half a year, to write the patent. And then there's this back and forth with the patent where the claims are what matter, and you claim everything, and then the patent office says, no, you can't have that, because look, this thing does that you're claiming, so you can't claim that. And there's this sort of negotiation back and forth, and it took 2 years, which my attorney said, that's pretty fast, actually. And so we got the patent July 19th, 1988, and here are figures from the patent. So these were made by a draftsman, and they're kind of based on my drawings, but they're done in the proper style. And one other thing was I didn't have a prototype that showed it, but I knew that you could make one end of the teeth thicker than the other end. You can see it there in the top left, and it would cause the pole to bend. So you could sort of pre-program whatever shape you wanted the thing to zip up into, which I thought was a nice property of them. And then we had this nice claim. So just to review, with a patent, what really matters is claim 1. So you say, here's what I claim, and then you have all these other claims that say the invention of claim 1, wherein, and you have all these details on it, the things that you actually did. But claim 1 is a very general picture of what you're claiming, and it may be much more general than what you've made a prototype for, but that's okay. And so first of all, I thought my attorney did a really good job. He wrote really well. And then claims have this weird form. It's all one sentence. It can't be more than one sentence. So it's this huge run-on sentence. And I won't read it to you, but I thought he did a very good job of making a nice claim 1 for the patent. For example, you see the A there. It says at least 3 flexible columns. Well, I only showed 3 flexible columns, but he wants to make it as general as possible, so it has at least 3. Okay, fine. And then I translate on the right what the stilted language of the claim actually says. So a rough summary of the claim 1 is a zipper with 3 strands with teeth attached to the strands. Those teeth interlock at the ends and are spaced properly to zip up, and there is a slider for interlocking the teeth. Wonderful, nicely general. It captures what I did, and all sorts of little tweaks you might imagine making on top of what I did are covered by claim 1. So I was very happy with that. Okay, So I've done the patent part. Happy with the patent. Now I still have to make a prototype so I could not be sort of laughed out of whatever company I go to and show something that really gives evidence that this thing might be valuable. And I just felt certain that I needed to make an injection molded plastic tooth. I mean, make hundreds of them. And so I needed to make a mold. And I talked with, so again, I had to hire other people. I talked with these mechanical engineering consultants, and they said, well, it's going to be about $2,000 for a mold. And, that's a lot. And then that's if you got it right the first time, it'd be $2,000. But surely you're going to have to fix it and try different designs. So maybe it'd be 2 or 3 times, 2 or 3 iterations. So that's going to be like $6,000. And then also these consultants themselves, they were expensive. So I'm telling you, I'm beginning to have doubts about this thing, how much money I want to spend on it. So another thing was, I wasn't totally sure that my killer app, tent poles, was really a need that had to be filled. Like maybe the current poles, like shown there on the right, maybe they were good enough. These little straight segments with a bungee cord inside, and you just kind of hook them together, and the thing sets up pretty quickly. So do we really need a new kind of tent pole? So I wasn't sure. Okay, and then I hired these mechanical engineering consultants, and wouldn't you know, they came up with a different design. They said, well, we think 3 strands is too complicated. Here's a 2-strand zipper that becomes a rigid structural support, and I kind of liked my design better, but they were mechanical engineers, so they probably knew what they were doing, and it kind of confused me as to whether I wanted to pursue their design for the zipper or my design. And if I pursued my design, even though theirs was better if it was, then what is this, just a vanity project? Why am I doing that? So I had a back and forth with them about what the two-strand version would look like. And anyway, so here's a list of some of the concerns I had. Do I go with my 3-strand design or with their 2-strand design? A little bit. Also, I wasn't sure I wanted to devote my life to this. Like if I really wanted to make this happen, I should go to companies and really devote a lot of money and time to make these prototypes. And I wasn't certain there was a need for it. And it was probably going to cost me around $10,000. Did I want to spend that? So in some ways, that kind of validates the whole premise of the Innovative Design Fund, that it really was the cost of making a nice prototype that was keeping me from making this thing. Okay, so now here's a timeline of the patent's life and my life, okay? Worked at Polaroid, 81 to 86. My wife and I lived in China for a year. And then I went back to grad school, 88 to 92. I worked at a company, Mitsubishi Electric, for 9 years, and then became a faculty member at MIT since 2001. So in blue is the events in the patent's life. Okay, we filed 86. It was awarded 1988. I hired the mechanical engineering consultants. It looks like it's going to cost $10,000. And then it kind of became this thing that was just hanging over my head for literally years. Oh yeah, I should work on the zipper. I should. Really what I had to do, my prototype was just flat wooden pieces. And if you think about it, it's kind of like an Escher staircase. They can't be flat, otherwise they don't all fit together in a triangular pattern if you make it like a 3-sided log cabin, and they have to bend a little bit and where they connect with each other. And the fact there's long wooden teeth, they had some slop, and I didn't have to. It worked even with these being perfect rectangles. But to really make the plastic design, they'd have to bend and have to kind of work out exactly how that would be. So there was this extra work I had to do, and it was something that I always should be working on, but I kind of put off. I don't know, maybe you have these things in your life. And also I had other things I was doing that satisfied my desire to create things and really focus on technical work, and that was graduate school and then work after that. Let me tell you the low point of this. The low point, so when you have a patent, they don't make you pay the whole filing fee all at once. They actually spread it out over the life of the patent. So if you decide halfway through your patent's life that you really don't want to assert it anymore, you can just stop paying the filing fee and the patent disappears, but you don't have to pay all that extra money. But I kept on paying. And perhaps the low point was in the last maintenance fee, 5 years before the patent expired, it was going to be $1,600, $1,580, to let the patent last another 5 years until the final 17 years were up. And I knew that there wasn't going to be anything that came out of this patent for me financially. I knew it, and also the later a patent is in its lifetime, the less value it has. Why would a company pay a lot of money for a patent that's only going to last 5 years from then? So I knew it wouldn't have a lot of value. I knew I wasn't getting around to it. And I knew that it was just equivalent to taking $1,600 bills and just throwing them away in the air, but I paid it anyway. I didn't want it to go away, so I paid $1,580 for the final maintenance fee in 1999, and then the patent expired 2005. Okay, so that was kind of, it sounds like a sad outcome, okay? I put all this time into it, didn't pan out. So what did I get out of it? Okay, I learned a lot. I learned a lot about entrepreneurship, about inventions, about patents, about making prototypes. And then how did I benefit professionally beyond that? Well, there were 2 job interviews I had, one at Mitsubishi Electric and one at MIT. And in both those interviews, I said, oh, I invented this cool thing. Let me tell you about it. And so I told them about the zipper. And it probably wasn't what pushed me over the edge, but it maybe helped convey that I was someone who did fun, creative things. So there's a slight professional benefit there. And that was it, okay? So kind of a sad story at this point. When I reviewed my materials for this talk, I found one other thing that I was kind of regretful for, and that was, let's see, at that time there was this thing called the kryptonite lock, bike lock, I guess it's still around now, and they always advertised how they had this design award from the Museum of Modern Art. And so I actually wrote to them in 1986, the Museum of Modern Art, and said, the kryptonite lock, they refer to a Museum of Modern Art design competition. I have something I'd like to submit. Can you tell me about it? And by golly, the Museum of Modern Art wrote back to me and gave me the steps I need to take to apply for this design competition. I really wish I would have followed up on that, but I didn't, okay? And anyway, my wife tells me, you still can. Okay, fine, maybe I will, but anyway, so that was another thing I wish I'd followed up on. But then the story gets better. So now I'm a professor at MIT. Last spring, this postdoc from Stefanie Mueller's 3D printing group, a research group focused on 3D printing among other things, came to my lab meeting and showed us about the cool stuff he was working on. And he made these structures with cables between them, between things that looked like teeth. So here is one. So you can see it there. And here it is in person. So it has these cables connecting these teeth, and you can pull it, it moves around. And I thought, wow, this looks kind of like my zipper. I wonder if these cables can let us bypass the ever awkward slider that was kind of always a problem. Maybe we can use the cables instead of the slider. So I talked to Jiaji and showed him the patent for the zipper and talked about it with him, and he was way into it. He said, thank you so much for sharing your fascinating 3D zipper design. I experimented with maybe using cables. Now, it turns out that the cables didn't work instead of a slider, but he was hooked on the zipper anyway, and we started collaborating together. So he would come to my office and we would talk about ways that you might design this thing. It was really just 1 or 2 conversations I had with him, and he went back to his group and recruited this army of graduate students and UROPs to work on it. And I should say, this is why we're in academia, okay? You ran into, by chance, I ran into this really hot researcher postdoc who just wanted to run with this thing, and he did. So let's see, first iteration, he showed me this version of the teeth. Again, this is 3D printed, is we made this prototype. And you could use the same material for both the teeth, if it's made, the solid teeth as well as the flexible band connecting them. And here he hadn't made the slider yet, and showing how kind of awkward it was to put it back together without a slider. And that was one iteration. And then we talked more, and he made just a beautiful set of applications for it. And their home community is the CHI, the Human Computer Interactions Community. So they wrote up a paper on this thing they called the Y-zipper, and all these applications. I want to show you this wonderful video that he made for the submission for the paper. Here it is. Much nicer slider than mine. And he, went to town with the curving aspect. And added these new things. He added, a motor to the whole thing, so you can extrude the stuff. And you can have the slider motorized and drive up along the cable that it was making. So here's some applications, a cast on the left. Now, because it's a human-computer interaction paper, they show the interaction of designing it. Also compare this prototype to my wooden prototype sawed with a little saw. So this is a cast. Now it's flexible, but suppose you want to have it rigid for some task. You make it rigid. And this combines the cables with the zipper, but here, so he extrudes this shape into whatever design you want to create. And this, I love this. He made a little robot with legs that grow and shrink as desired. So the teeth roll up into those Mickey Mouse ears at the top. You can make it small and go under the obstacle. Or if you want to go above an obstacle, you can just increase the length of your legs, and there you go. And each step, the thing moves a little bit in and out, so you don't need knees if you have this. And then finally, here's the tent. A little motorized version. So I want to say this part B, the 3D printed part, that's almost all Jiaji Li's work, him and his team. I had a few conversations with him, but basically he just went off and did it and came back with this amazing work. So here's pictures of the 3D printed system, and he really understood the whole thing, how the teeth need to bend where they connect, and he got them to zip as they should. And they submitted to CHI and it got in. So it'll be presented in Barcelona in 2 weeks. So that's the story of this 4-decade-long project. And well, a number of things I really like about it. So one is this really nice connection between Bonnie Cashin's fund, which kind of laid the groundwork to spawn ideas, at least in me it did, and so that led to this prototype, which 40 years later led to this really nice prototype. Let's see, so so some things to note. Note how prototyping has changed over 40 years. You know, so the little wooden thing in the bottom left is, you know, I went to the charrette design store to buy these wooden models, little tiny pieces of wood that architects would use to build their house models with. And so I made the prototype out of that. And then now 40 years later, of course, it's all 3D printed, computer designed. And then also, I should say, my own goals changed over 40 years. Originally, I wanted to patent and make a whole lot of money. That didn't play out. But now, my goal, I just wanted to have impact. And I'm happy to just have impact. So now we're publishing it. We're going to put the designs online so people can download the designs onto their 3D printer and make these teeth themselves. And so you know, now my goal is just to have impact. And again, I should stress that the part B of this was all from the guy on the right, Jiaji Li, and his team. So it's a wonderful 40-year thing, and you know, my 1985 self would be very happy with the outcome. So that's the story. Thanks. Questions or comments? Yeah. Oh, yeah.
All right, thank you for this amazing talk. It was really so fun to hear about the whole story and the journey. And it's also very interesting to hear about how 3D printing influenced it, going from like the $2,000 prototyping fee for a single mold to being able to make all of these designs with, like, who knows, a desktop 3D printer perhaps? Yeah. So I think one obvious question is, like, do you hope to go and make some of those applications with now that you have the working prototype?
Right. Forgot my prop. Here is one of his prototypes, and you can see it's floppy and then becomes, you know, solid. I don't personally have a need to do it, but I want it to be available to people to play with. I mean, I think the design space is really big, and I'd love to hear what the world wants to do with it if they want to do anything. So no, I don't think I want to do it. I've really been impressed with what he made and he and his team made. And then, you know, that whole angle of patenting and licensing the patent to make products, I kind of know by now how much work there would still be ahead to do that, and I don't really want to spend my time doing that, but I want to have it kind of be available to the world if it makes sense. Someone else can do that. Well, I want to thank you so much for tolerating a talk in an AI series that really had nothing to do with AI. Maybe the robotics at the end was a little bit of AI, you know, but it's really all about entrepreneurship and things over time and maybe sticking with things. Anyway, it's a lot of fun sharing it with you, and thanks a lot.